Hey guys, my name is Amish and today I'll be doing a physics O levels paper. It's ATP, which is a short form for alternative to practical, and this is for GCE level. And I'll be writing the solutions to a past paper, and I'll be explaining the solutions. And this is for Anab. And I've made another video on giving feedback on essay writing of IELTS academic. Uh, if you haven't watched that video, do watch it. It's the last video that I've made, the one before this, which I'm making now. So do watch that, and let's get right into it. So, guys, the first question is: a student is asked to find the focal length f of a lens. He uses an arrow-shaped slit in a piece of card as an object, as shown in Figure 1.1. The object is placed at one end of a meter rule, and the lens is fixed a distance u from the object, as shown in Figure 1.2. The slit is illuminated from behind using a lamp. A screen is then placed on the meter rule so that a sharp focused image of the arrow is formed. The distance v from the lens to the screen is then measured. So the question is: explain how the student ensures that the image is sharply focused on the screen. Okay, so this basically means it's asking you to, like, how will you find out that the image that is produced on the screen is a perfect image. By perfect image, I mean, like, it's not a physics term, but I'm using it like a perfect image is like a sharply focused image. So the most clear, the most sharp, the most focused, most visible image, how will it be formed? So the thing to do that is, the way you do it is that you basically uh, you have placed the object, you have the lens in the middle, and then you have the screen. So it depends on the screen. So you basically move the screen backwards and forwards, and what it does is that you keep moving it backwards and forwards until you see on the screen that a sharp focused image is performed, and you can clearly see it. So if, for example, if I'm moving it here, it's not so focused. I'm moving it closer to where it's getting focused, and I'm moving more closer, so now it's perfectly focused. So you basically observe the screen and you move it backwards and forwards to observe. So I'll now explain in Urdu, in Hindi. So अना basically आप जो है स्क्रीन प्लेस्ड होगी, उसमें फोकस्ड इमेज, जो फुल क्लियर विजिबल इमेज है, वो कैसे पता चलेगा? हम स्क्रीन को मूव बैकवर्ड्स एंड फॉरवर्ड्स करेंगे, आगे पीछे करेंगे, जब तक हमें ये नज़र ना आ जाए स्क्रीन पर कि ये परफेक्ट इमेज है। परफेक्ट इमेज से मतलब कि ये शार्पली फोकस्ड इमेज है, तब तक हमें पता नहीं चलता, तब तक हम मूव करते रहेंगे। ठीक है, तो ये जो है, ये है इसका कॉन्सेप्ट। So the question B, I mean 1B, is figure 1.1 is a full scale diagram showing the positions of the object, center of lens and screen when the sharp focused image is obtained. Take measurements from figure 1.3 to find U and V. Okay, so this is U. I've just used a ruler to, like, show the arrowheads. So this is U. Okay, and because u, if you view the previous page, u is the distance between the position of center of lens and the position of object. So I measured it using a ruler and 6 centimeters. For v, it was the distance between center of the lens and position of screen, and it was 4.3 for me. So I wrote 6.0 and 4.3. I wrote 6.0 because it's better to write in two significant figures. So instead of writing 6, it's better to write 6.0, because every time there's a zero after a decimal point, it's considered a significant figure. Okay, but if a zero is like, if the starting zeros are if for example, if you have 0.006, then we only have one significant figure. The starting zeros are not significant. The starting zeros after the decimal point are never significant, and before the decimal point, the starting zeros are never significant. But after a decimal point, all of the zeros are significant. Okay. So the question is, the focal length of f of the lens is given by the equation f is equal to uv divided by v plus u. Calculate f using your measurements in b1. So this is an easy question, you just substitute it. So f is equal to 6 times 4.3 divided by 4.3 plus 6. It's 25.8 divided by 10.3. The answer that you get on your calculator is 2.04854369 blah blah blah. And you basically write to two significant figures. And how do you know that? Because ignore this, ignore this. If you observe this equation, the previous one, I'm telling you to ignore that because it's the simplified version. But if you look the equation, we have 6.0 times 4.3 divided by 4.3 plus 6.0. So we always round the number to the we always round the answer to the least number of significant figures that we have in the initial question. So here we have two significant figures. The minimum is two significant figures because 6.0 times 4.3, these are two significant figures, and you basically uh, calculate, and then the answer that you get is 2.5. I mean 2.5048, but then uh, you round it to two significant figures, so it becomes 2.5. And the reason why you round it to 2.5 is because you round it to the least number of significant figures that we have in the question. So the least number of significant figures that we have in the question is 2, because 6.0 and 4.3 are two significant figures, so it's 2.5. So just one way the student ensures that his value for f is accurate. Okay, this is like a uh, very orthodox type of question, but so the only way, like this is like you should memorize this answer because it keeps coming up again, again, and again. So the way you would ensure that the value for x is accurate is you'll basically repeat the experiment. I mean, just say that the student repeats and works out the mean or the average value. uh, I did a slash because mean and average mean is almost the same thing. So, but you can say average. You can say the student repeats and takes an average, or the student repeats and works out an average value. Okay, so that is it. Now let's move to the next slide. Okay, so the second question is, students carry out an experiment to find the mass of a meteor. She uses a number of identical metal rings and a pivot. Each ring has a mass of 3.3 grams. The student places the pivot under the 45 centimeter mark on the meter rule. She then places rings one at a time on the meter rule at point A, 5 centimeters along the rule. She adjusts the number of rings until the rule is as close to balance as possible. She records the number of n of the rings needed to balance the rule. The rings are circular with a central hole as shown in figure 2.2. Measure the outer diameter of the ring. Okay, so outer diameter means like the full diameter, like from the center, like the all the way across. Okay, so I used a ruler to do this, and you draw it in the middle. You draw a horizontal line in the middle of the circle, and then you basically measure it with a ruler, and it's 2.2 centimeters. I haven't done this question because I don't have a compass. I'm sorry for that. But I'll tell you how to do it. So it will be something. This is an inaccurate version, but I'll give you the idea. The the center of the circle of the ring, because ring is circular. So the center of the circle should be at the 5 centimeter mark. All right. So the way you would do this is you just draw a circle, something like this. I'm in the middle of the circle. Oh, oops, not like that. Just a second. Uh, you draw a circle. Oh, okay, just a second. What you could do is that you could draw like a symmetrical line above the 5 centimeter mark. So something like this. Like this is you're pretending this is the middle of the circle, and then you just join like that. Like that, and then you erase those lines. Okay, then you erase these lines, and this will show that the center of the circle is at 5 centimeters mark. I'll explain it again. I'll explain it in Urdu now. So अनब आपने क्या करना है कि ये 5 सेंटीमीटर्स का मार्क है, यहाँ पे आपने लाइन, ये डॉटेड लाइन बनानी है, डॉटेड लाइन, यू शुड ड्रॉ डॉटेड लाइन above the 5 centimeter mark. और फिर आपने एक एक ये आधा सर्कल यहाँ से बनाना, सेमी सर्कल, और दूसरा सेमी सर्कल उस लाइन से बनाना है. इससे ये हो जाएगा कि ये आपको श्योर हो जाएगा कि जो 5 सेंटीमीटर मार्क है वो मिडिल इन द मिडिल ऑफ द सर्कल है. ठीक है, so you do it like that. Or if you're really good at drawing, you could draw it freehand, but I'm not so good. I probably need like a compass. Okay, so part II is explain why the student adds the rings carefully one at a time. Um, so, so the answer is that so that the student knows when the meter rule is close to balance. So, like imagine if the student like uh, carelessly adds the rings, like quickly adding the rings, what will happen is that you wouldn't be able to observe the values carefully, and the pivot will be moved, and the ruler will probably tip off, will topple, will fall down. I mean, topple is a good word, so it will topple, by which I mean that it will fall off. So it will completely destroy the experiment. So you should add carefully, like slowly and carefully, so that you know when the meter rule is close to balance. All right, let's move on. Okay, so now let's do the B part. The distance L between the pivot and point is changed by moving the pivot closer to A. The student repeats the experiment for different values of L and draws a table of results as shown in table 2.1. I part is on figure 2.4 on page 7. Draw a graph of N on the y-axis against uh, L by centimeters on the x-axis. Start your axis from 0, 0. Draw the best fit curve, and use your graph to estimate the number of. Okay, now we'll come back to the later. Let's go on to the graph. Okay, now I apologize for this messy graph. Okay, but as long as you're understanding, I'm all right. Okay, so basically I've drawn the table that they have drawn in the previous page. I've drawn it over here. Okay, uh, and I'll first tell you how to work out a scale, like how to choose a good scale, because sometimes it becomes confusing on like what units, I mean what increments to use. Uh, so let's do it for L L divided by Cm first. So let's do for this one first. So on the table we have 40, 35, 30, 25, 20, 15. Okay, so the first step that you do is that you subtract the highest value by the lowest value. So you not divide, subtract, I mean. You subtract the largest value by the smallest value. So the largest value on the L divided by centimeters table, like this side, it's 40, and the lowest value is 15. So it becomes 40 minus 15, which is 25. Then you count the number of horizontal squares. In this case, they are horizontal, not vertical, because L is on the x-axis. So L will be over here because L is the independent variable, and it said in the question that L is on the x-axis. So you'll count the horizontal. By horizontal, I mean left to right. Okay. So you'll count the squares this way. Okay. You'll count how many big squares are there, not like the small bits I'm talking about the big square. So this is one square, uh, one big square, this from 0 to 6. This is two squares, three squares, four squares, five squares, six squares, seven, eight squares. So there are eight horizontal big squares. Okay. So after you have worked that out, what you do is that you divide the value that you got by subtracting the largest and the smallest value, which was 25. You divide 25 by 8 because we have 8 horizontal squares, and then you get a value of 3.125. What you do then you multiply 3.125 by 2, and then you get 6.25. Now this is the most tricky part. So you have done 25 divided by 8, that's 3.125. Then you multiply it by 2, which is 6.25. Then what you do is that you choose a scale, you choose an increment. So by increment I'll explain in Urdu. So by increment I mean कि किस नंबर से वो जो है स्केल वो इंक्रीज होगा. जहाँ इस ग्राफ में 0 है, 6 है, फिर 12 है, फिर 18 है, फिर 24 है, फिर 30 है. हर बार 6 से इंक्रीज कर रहा है. Every in this graph, it's the number on the x-axis. The scale is increasing by 6 each time. We have 6, 12, 6, 18, 24, 30. So it's increasing by 6 each time. So, and why is that? Because we have worked out it's 3.125, then we have multiplied by 2, it's 6.25. Now what you do is that you choose a value between 3.125 and 6.25. So this number here and this number, you choose a value between them which is the most suitable. Now I could have chosen 5 as well, because 5 is a sensible value. So it would have been 5, 10, 15, 20, 25, 30, 35, 40, 45. But uh, but 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 I chose 6. But it doesn't really matter. But it, you have to choose the most sensible, the most easy to do. Probably for some people, 5 will be easier to scale. Probably it's easier. 0, 5, 10, 15. Yeah, it probably will be easier. I didn't notice it before. So, but you choose a value between 3.125 and 6.25. It could be 5, it could be 6, and then you increase it by that number each time. Okay, now let's go for n. So I've done this. Okay, now let's go for n. So it's 4, 9, 70, 38, 43, 70. The largest value is 70, the smallest value is 4. What you do is you subtract 70 by 4, which is 66. Then you count the vertical squares because n is on the y-axis. So you count the vertical squares. So it's 1, 2, 3, 4, 5, 6, 7, 8, 8 vertical squares. Fantastic. So what you do is that 70 minus 4 is 66. You divide 66 by 8, which is 8.25. I've written here. Sorry for my messy handwriting, but 8.25. Then you multiply it by 2. It becomes 16.5. So now you have to choose a number between 8.25 and 16.5, which is the most suitable for the scale. So I've chosen 10 because 10 is in between 8.25 and 16.5. So I've increased. Sorry for this mess. Okay, I really apologize for that over here, but it's increasing by 10. So 10, 20, 30, 40, 50, 60, 70, 80. Then you just plot the points. Make sure they're crosses. Make sure they're crosses, small crosses. Don't draw like big crosses. Draw small crosses, and don't draw. I mean, crosses are the best. And the middle of the cross tells you the values on the x and y axis. All right. Then you plot the points. Then you just draw a freehand curve without a ruler because it's saying, I think, best curve. So curve is always without a ruler. It's a freehand. Then you just after you have covered all the points, you just extend the line that's following the pattern. So you just extend it. So this is how you do it. Okay, now I'll get back to the previous questions. All right. So we are done with the graph. Finally, the II part is use your graph to estimate the number and 18 of rings required to balance the rule when L is 18 centimeters. Show you are working clearly on your graph. So let's do this again. Let's get back to the graph. So here's the graph. So what it said was when L was sent, find the value n 18 when L is 18. Okay. So what you do is you just draw a line like a dotted line vertically until it touches the curve, until you draw a line vertically from 18 centimeters until it touches the curve, and then when it touches the curve immediately draw a horizontal line from that dotted line and then read the value over here. So it's 52 in my case. So the value of n18 is 52. Okay, guys, so we are here with the answer of 52. Then the third part is theory suggests that the mass sum of the material is given by the equation. This is the equation. Use your answer when I to calculate a value for m. Give your answer to two significant figures. So m is equal to 3.3 times 52, which is n18 times 18.0, and then divide by 45 minus 18. So we get a value of 104.4. You round it to two significant figures, it becomes 110 grams. So this is the answer. Name a piece of apparatus that can be used to check whether the theory is correct or not. It's basically saying how can you measure the mass. You name the apparatus that's used to measure the mass, because here we are talking about the mass. Here we're talking about the mass. So it's balance. We use a balance to measure the mass. Then it says suggest one way in which this method of measuring mass of the material can be improved. So I said that use a combination of heavier rings and smaller rings to get balanced. So what this basically means that when you have a balance in like the instrument that's used to measure the apparatus that's used to measure mass, the balance. So I'm saying that use a combination of heavy rings and smaller rings on either side, on left and right hand side, in order to get balance. And what that will do is it will improve the experiment because there won't be any error in the mass of the rings. Like if you only have one type of rings, like small rings, which are like 3 centimeters long, and they have a diameter of 4 centimeters. Let's imagine they have a diameter of 4 centimeters, and they're this ring X. And if you only use ring X, then it's not improving the accuracy of the experiment because we are not sure if the mass is actually correct or not. So what we can do is to ensure a better, more accurate value, more reliable result. We could use a combination of heavy and small ones to get balance on either side. Okay, let's move on. Okay, here we have Question 3. A student investigates how the resistance of a filament lamp changes as the potential difference V across it changes. He uses the circuit shown in figure 3.1. On figure 3.1, draw a symbol for an ammeter and the symbol for a voltmeter in the correct positions for this investigation. The student takes two different sets of readings of current and potential difference. Suggest how he adjusts his circuit to do this. Okay, so what I said is use a battery of different voltage because it's saying that he takes different settings of reading of current and potential difference. So this basically means potential difference is voltage. Okay, it's another word for voltage. So what he's saying, what the question is saying, that how will he adjust his circuit so that he can measure different amounts of voltages or different amounts of potential differences. So you basically use a battery of different voltage. That's it, because voltage depends on the battery, right? So you use a battery of different voltage in order to get different current and potential different readings. II is he adjusts his circuit so that the voltmeter shows 4 volts, and he reads the ammeter. He repeats the experiment at 8 volts. This shows the readings. Okay, record the values of I shown on the meter for each voltage. I is basically current. Okay. Uh, so when V is 4 volts, I is 1.20, because if you look at this meter, it's 1.1, 1.2, 1.3, 1.4. Sorry, it's each time it's increasing by 0.05. So this would be, so 2 units are equal to 0.1. So 0, that will be 1.1, that will be 1.2. It's 1.20. I wrote it to three significant digits. When we've 8V, uh, I is, so this is 1.5, 1.6, 1.65. So it's 1.65. Okay, 1.6 of amperes, which is the unit for current. So the next question is, use the equation R is equal to V divided by I to calculate the resistance of the lamp at 4 volts and at 8 volts. State the units. So we just substitute the values. So R is equal to 4 divided by 1.2, which is 3.33 ohms, which is the unit for resistance. Then it's 8 divided by 1.05, 1.85 or something, and it's 4.85 ohms. C is straight to physical changes in the lamp that are observed as the potential difference V is increased. So when the voltage is increased, because potential difference is equal to voltage. So what happens when the voltage is increased? What happens to the lamp? When the voltage is increased, the lamp is it's brighter and the lamp is hotter, because the temperature of the lamp goes up. So lamp is hotter and lamp is brighter, and it's physical changes. Okay. It's asking a student has a thermometer which has no temperature markings as shown in figure 4.1. He finds the length of the liquid column when the temperature is 0 degrees. State the apparatus he needs to do this and explain how he uses the apparatus. You may use a diagram if you wish. So it's saying that this has no temperature markings, and he wants to find the length of this liquid column, and state the and he basically finds the length, and when the temperature is 0 degrees, and 0 degrees is the melting point of water, and at 0 degrees the water freezes to ice, and freezing point and melting point are equal, which is 0 degrees Celsius. And it's saying state the operator he needs to do this. So how will he calculate the length, and I explain how he uses the apparatus. I didn't draw a diagram. You could draw a diagram. I'm terrible at drawing diagrams, so I didn't. What he'll do is place ice in a container or a beaker, and then place the thermometer in melting ice. And when he places the thermometer in the melting ice, uh, it's the thermometer reading will be at 0 degrees, because the temperature of melting ice is 0 degrees Celsius. So the liquid column, the liquid inside the thermometer will automatically move to the position of 0 degrees Celsius. So you place ice in a container, you place the thermometer in melting ice, and the liquid column will move to uh, the correct 0 degrees Celsius marked on the thermometer. Okay. The next question is, he finds the length of the liquid column and the temperature is 100 degrees Celsius. State the apparatus he needs to do this and explain how he uses the apparatus. You may use a diagram if you wish. It's the same question. So uh, water boils at 100 degrees Celsius, so it's the same procedure. So you add boiling water to a beaker, and then you place the thermometer in boiling water, and the liquid column will automatically move at the 100 degrees Celsius on the thermometer. Okay. So it's the same thing as the 0 degrees, but in the 0 degrees you added a melting ice, but in 100 degrees you're adding boiling water, and then you're placing the thermometer inside the boiling water. Then at C part is it suggests how he then uses thermometer to find room temperature. So after placing thermometer in melting ice, the liquid column is 0 degrees. So he marks it. He calibrates the thermometer, and then he places it in boiling water, right? And then he marks the 100 degrees Celsius. He basically calibrates, which means to mark. And what then he does is after calibrating the thermometer, he could place the thermometer inside the room, like on a table in the room, and then he could read the temperature on the thermometer, and whatever wherever the thread moves, wherever the liquid column shifts is the correct room temperature. All right. So calibrate the thermometer and then place the thermometer in the room and then read the temperature on the thermometer. That's it. Okay, now thanks for watching my video and best of luck. And I wish you all the best for your exams and other guys as well. I wish you all the best for exams and please like, subscribe, comment, and click on the bell icon and share my video. And best of luck. Take care. See you. Bye bye.